First of all, I'd like to thank the university, the department, the sponsors of this distinguished lecture series for the invitation. It's really an honor. I'm coming to you today from the Franklin College of Arts and Sciences here at the University of Georgia, where a little over 2 months ago, I entered the deanery, as those of us in academia say, by becoming an associate dean, but I still maintain a professorship and engage in research as well. So I look forward to discussing with you today. I would like to give a big hello to my colleague Julie Winkler, who I did see virtually in the audience. So hello to Julie. We've worked over the years together at the American Meteorological Society and so forth. So pleased to see you on. So I want to launch right into a discussion that I've been sort of toying with for about a year or two now in terms of convergence of what I do as a scholar. It will have bits and pieces of my research, have my thoughts on climate communication and engagement, and then just broader thoughts on how we as a science community think about wicked problems in society. So I want to use the title today, Cloudy with a Chance of Science, shaping a discussion at the intersection of wicked problems and society. So if you're ready to go along with me, I think that this will be a very useful engagement for all involved, and I look forward to your discussions and questions. So the wicked problem of COVID-19, start there because I think it's something that's fresh in the minds of the public and policymakers and scientists. The pandemic's complexity transcended health, environment, economy, and social boundaries, according to Rex Weiler. And it's a good starting point to help me define what wicked problems are. And you can see in this diagram the complexity that we're trying to convey. So what are wicked problems? So in 1973, design theorists Riddle and Weber introduced this term wicked problem. And it's a term that I came across in the media, but I wanted to know a little bit more about it. I didn't want to sort of know what I was reading in, the local media. I wanted to sort of dig a little bit. And so, I found the scholarship here and then the term, and they used the term to draw attention to the complexities and challenges of addressing planning and social policy problems. Now, that's COVID-19 in a nutshell. But it's also other things. Here are some of the attributes of wicked problems. So as you look at this list, and I'm not going to sit here and read through all of them, but I put it up so because in a Zoom format, it does allow us to really see these clearly. I'd like for you to take a step back at this. This is kind of the interactive part of mine. I'd like for you to take a step back and look through this list and think about your scholarship. Think about your master's thesis. Think about your dissertation or your body of work if you're a faculty member or if you're in a broader community. What are you working on? Are you working on a component of a wicked problem? Are you working on a wicked problem? They don't have definitive formulation. They don't have stopping rules. Their solutions are not true and false. There's no way to test the solution. All wicked problems are essentially unique. Wicked problems can all be described as the symptom of other problems and so on. These are attributes of wicked problems. Now, keep in mind that this term emerged from sort of a planning and social design community. I'm a climate scientist. I would argue that climate change and the climate crisis indeed is not only a wicked problem, but it has a sort of cascade or multitude of wicked problems connected to it from societal, agricultural, water supply, energy, health, infrastructure, national security, and so forth. So let's set the stage because we need to kind of establish the fact that climate is changing. We know this. I think this is an audience where I'm preaching to the choir, if you will. But this is data from NASA, a really nice animation. And there is an animated version of this that I like to show from time to time as well. But this is, I think this is a very, yes, a very sciencey distribution figure. Wouldn't necessarily show this in a public format, but this is an academic audience, so I'm happy to use it. And what we see is over time, from the 60s up to roughly the present, that the mean temperature anomaly has shifted to a warmer state. So what this suggests is that things that were sort of on the warm or hot end of the sort of distribution in the 60s is now close to a normal event in 2022. And the extreme heat events in 2022 were just unforeseen. They're just other things. They just are off the chart. They represent this so-called new normal. That's why, for example, the 2021 heat wave in the Pacific Northwest US, attribution studies, those studies that try to link current weather to climate change, suggest that that heat wave was 150 times more likely because of climate change. So that's one of those events out here on this tail of the distribution. But here's another part of that wicked challenge. Look at how the the cold tail has shifted. So what was normally sort of colder temperatures or minimum temperatures overnight, those have shifted to a warmer state as well. So that means when we have these brutal heat waves, for example, the nighttime temperatures don't cool as much as we'd like for them to. And that's where health challenges come into play. I was looking at the heat wave in Phoenix or out in the desert Southwest this past summer. Yeah, everyone was talking about the 118-degree temperatures for sustained days, but what caught my eye was that at midnight, it was still close to 90 or above 90 in some cases. And that's where health challenges come into play, particularly for vulnerable and marginalized elderly communities and so forth. The headlines have already told us this, but I just want to reinforce it. 2023 was the warmest year on record, and it was warm by quite a bit. I mean, if this were a Olympic race, a 100-meter dash, this is like breaking the record by several seconds. I mean, it lapped the field, if you will. It was not even close in some regards. Now, clearly, being within an El Nino year certainly helped that. We tend to see a bit of an increase or a boost in the background climate warming during El Nino years. The previous warmest year on record was 2016, which was also an El Nino year. What hasn't perhaps not gotten as much attention is 2023 was also the most costly in terms of weather climate disasters. We had more billion-dollar plus lost weather climate disasters than any year since at least NOAA has started keeping that record in 1980 or so. And in fact, I just talked to the scientist at NOAA that compiles that list every year for an episode of Weather Geeks. As you heard from Jack in the introduction, I do host Weather Geeks, which is a podcast for the Weather Channel. So if you just like to geek out, as I do, on weather and climate topics, feel free to check out the podcast wherever you get your podcasts. And I will say, Jack, I've hosted the podcast since 2018, but we also had a TV show version of Weather Geeks on the Weather Channel for about 4 years before that as well. So definitely have been at the Weather Geeks in the Weather Geeks family at Weather Channel for some time. So to sort of bring this around, many wicked challenges sit at the intersection of science, perception, and society. And so those two words, science and perception, is what I want to focus on in my discussion with you today in the Carson lecture. Well, what are we seeing here? This is what I characterize as wicked and compounded. What we're seeing here are sort of deaths, social vulnerability scores, and hurricane tracks in the Gulf of Mexico during COVID. Now, I am actually on a National Academy study right now thinking about how we address these compounded events, these periods where we had a very active hurricane season in the Gulf region in 2020 and 2021, and you had COVID. So again, let's pause as the audience and think about this question. if you are a policymaker or a decision maker, typically when you have a Category 5 hurricane approaching New Orleans or the Gulf Coast, we advise people to evacuate and move inland, perhaps even to shelters. What decision do you make when those shelters may be infested, if you will, with positive COVID cases? How do you handle that? That's a wicked and compounded problem. So, with that context, let's talk about what shapes people's perceptions when it comes to science, STEM topics. I mean, there was a lot of discussion at the time of COVID about vaccines, and there were factions of people that questioned the efficacy of vaccines. There are people that question climate change or the accuracy of weather forecasts. So, how did we get here? How did we get here? We look at this little cartoon on the left with the dinosaur holding the climate change as a hoax sign. How did we get here? Well, this was an old survey. I think it's about 10 years old now that I saw that showed the percentage of US adults and AAAS scientists, what they say about different topics. Now, what you will see, and this is disturbing to me, and it should be to you too, the more blue you see, the more disturbing that should be, because that's the gap between what scientists or experts say about a particular topic versus what US public says about that topic. There's a gap. So how did we get here? I want to explore that conversation today. So hopefully you're hopefully willing and able to go with me. And what shapes individual and institutional perceptions about science is the question of the day. So let's use shapes. I'm going to use basic shapes, circles, triangles, and squares, boxes, and so forth, to frame the discussion that we'll have today. So, what is shaping individual and institutional perceptions about science? Well, let's start with boxes and squares, being boxed in. People are stuck in the boundaries created by marinades. Now, I don't know how many chefs or sort of foodies we have in the audience, but oftentimes when you're preparing a meal, you will marinate the food. You will put it in either some type of sauce. And over time, that vegetable or that meat takes on the characteristics of that marinade. Well, we all have kind of grown up, developed in different political, cultural, racial, theological, geographical marinades. And so that in turn shapes in part some of how we see the world. So here are our marinades. Think about what your own personal marinades are that shape your viewpoints on multiple things. So let me pause for a second and talk about my marinade. So I grew up in a single parent home in Canton, Georgia. My mom was a teacher. I liked honeybees, so I used to catch them in the yard. I wanted to be an entomologist when I was about 5th grade. Got stung by one of those honeybees and almost died because I was highly allergic to bee stings. Went into anaphylactic shock. So 6th grade science project was coming around and I said, wait a minute, I need a plan B, pun intended, because I don't want to do a science project on something that could kill me. And so I was also interested in weather. And so I started making weather instruments from things that we had around the house and made a little weather model, if you will, for my community, won the science fair. And from that point on, I was bitten by the weather bug. But I didn't want to be on TV pointing at cold fronts and so forth. I was more interested in the hows and whys of weather. And so started doing my research and found out that Florida State University had a really good meteorology program. It was relatively close to my home state of Georgia. At that time, the University of Georgia nor Georgia Tech had undergraduate programs in this field. We do now, both of us. And so that's how I ended up at Florida State. From there, did my master's and PhD, had a 12-year career at NASA, and then joined the faculty here at the University of Georgia. So that's a little bit about my marinade. But marinades shape things. Now, many of us here in the South, and perhaps there in Michigan or wherever you're from, grew up thinking heat lightning is real. It's a thing, right? Now, by nod, and I can't see your nods, but how many of you have heard of the term heat lightning? Your uncle or your cousin probably saw the lightning flashing off in the distance and say, oh yeah, that's heat lightning. The heat of the day is causing that lightning. There's no such thing as heat lightning. I mean, what people characterize as heat lightning is just lightning off in the distance that's too far away to hear the thunder. And so, we have these marinades that shape our perspectives. There are a significant percentage of the population that believes that these two things can predict weather better than our weather models. The groundhog is a rodent. It has very little skill as a climate scientist, but yet it is fun and folklore. But there are people that will occasionally come up to me and say things like, yeah, Dr. Shepard, I don't believe these climate models, and I think climate change is a hoax. But then in the next breath, they'll turn around and say, well, what do you think of the groundhog's forecast? And I'll say, I think it's a rodent. And so these are things, again, shaped by our perceptions. I think there was a Penn State study that found that the Farmer's Almanac's only about 37% accurate, but yet I saw a CEO of a major Fortune 100 company quote that they were changing their logistics based on the Farmer's Almanac. Why not use NOAA Climate Prediction Center instead? The CPC provides very nice seasonal outlooks. So let's take that marinade and those perceptions and shift to the climate change discussion. Yale Climate Change Communication and the Center for Climate Change Communication at George Mason query the United States public every year. And so this is the most recent data, I believe it's 2022. And what they find is that America breaks out into 6 distinct groups. This study, in fact, is called the 6 Americas Study. And so what you see is that 26% of the American population is alarmed, 27% concerned. But I want to sort of go all the way down to this group, 11% dismissive. Now, this is the group that you've often encounter on Twitter. I guess it's X now. By the way, if you're on social media, definitely give me a follow on X, formerly Twitter, at Dr. Shepard, Dr. At Dr. Shepard 2013, because I like to talk about some of these things in my Twitter as well. Now, you might think that these are the most sort of significant group because they're the loudest, but you can see that they're only about 11% of the American population that's dismissive. Those are the ones that you don't spend a great deal of time focusing on because you'll just end up spinning yourself into frustration. You're not going to move the needle with that 11% dismissive. That's the uncle that brings up some wacky theory at your next Thanksgiving dinner. Sort of, you just be dismissive of the dismissive, if you will, because you're not going to move the needle there. This 89% is probably where we have traction, and probably don't need to really do much there at all with these groups. This is another way we can look at the evolution of that. So one of the things that you see is since that these two groups started to conduct this study, the alarmed have moved from 12% to 26%. So there has been a shift. The dismissive category has remained pretty constant. So the lesson there is that crowd is pretty much who they are. You know, what they say, it is what it is. It is what it is with that particular crowd. So they are shaped by those marinades or perhaps by misinformation or even other types of things. All right, so let's look at America as a whole, because you can go onto the Yale Climate Communication website and they have these interactive surveys and maps and pull downs. And so this is the estimated percent of adults who think global warming is happening. National average, by the way, is 72%. This is based on 2021 data. So here's Michigan up here. Many of you are Michigan State. And so it's always interesting to sort of see how you compare to the rest of the country. So clearly, as you get closer to Detroit and into the urban area, there seems to be, and perhaps even around places like Ann Arbor or East Lansing and so forth, there probably are some correlations. But you can, one thing that really is of interest and maybe a little bit of a surprise to you is that over the vast majority of the country, 50% or more does believe that climate change or warming is happening. Now I zoomed in a little bit more on Michigan because this is the question. This is the number of adults who think that climate change or global warming, as they call it in the survey, should be a priority for our president and Congress. And so let's zoom in on Michigan. Again, you can see some of those things that I pointed out as we get closer to Detroit. And I think these, as you see in other states, there's some really interesting regional sort of variations in perspective. And I think we understand that. And some of it is rooted in some of the things we're talking about today, those marinades, geographical, cultural, political, ideological, and so forth. So let's talk about belief systems and biases. I think that's one of the things that was reflected in that map that I just showed you. So often a question that I get is, do you believe in climate change? And the reason I show this building in Atlanta, I'm here in the Atlanta area, is because how silly would it sound if I were standing at the top of this building holding a ball and I dropped that ball and the person standing next to me said, well, do you believe in gravity? And I will say, yeah, I think that ball's going to fall if I drop it. Right. I mean, to me, that question is sort of in the same ilk as, do you believe in climate change? I mean, it's not a belief system. I mean, the tooth fairy is a belief system and Santa Claus. I just think this is a very ill-framed question, but yet we hear it all the time. And so we need to talk about these various things: confirmation bias, Dunning-Kruger effect, motivated reasoning, and what I call the trio biases: normalcy, optimism, and recency. So as you're listening to me right now, think about whether you're familiar with these terms. I think many of us are. So confirmation bias is this idea that we will seek out information that sort of aligns with our marinades or aligns with things we already somewhat believe or want to happen, right? We're all a bit guilty of this. I'm at the University of Georgia, right? So when football season rolls around again, I'm going to read blogs and things that say, hey, University of Georgia is really favored to win the national championship in football in 2024, right? And I'm going to say, yeah, we are. Of course we are. We've got the #1 recruiting class and blah, blah, blah. But there's a little confirmation bias there. Dunning-Kruger effect. Look at this expert on the left. He is talking about these equations and displaying his expertise. But then you got this guy holding a cell phone and says, no, some guy on Twitter says you're wrong. So this idea of Dunning-Kruger is, I want to go back here, this idea, Cornell psychologists published a scholarly work showing that people have sort of an underestimation of what they know, don't know, and an inflation or an overestimation of what they don't know. And so this is what we see often in various spaces in social media. Also motivated reasoning. People have reasons that they want certain outcomes. Here in the South, for example, we don't get as much snow as you get in Lansing. And so whenever there's even the hint or threat of snow here in Georgia, people get all excited. They go start buying bread, milk, and eggs. I guess they're going to eat a lot of French toast. But even if the forecast says 1 to 3 inches of snow, and it only snows 1 inch, people will say the forecast was wrong. Well, remember, the forecast was 1 to 3 inches, but people have motivated reasoning. They wanted more snow. And then there are these normalcy, optimism, and recency biases. So here is a Florida State football game. I'm a 3-time Florida State alum. So for those of you that follow college football, imagine how difficult the Orange Bowl was for me this year, because Florida State and Georgia played each other, and I did go. But nevertheless, how many of you can see the problem here with this image? This is a fully packed stadium with cloud-to-cloud lightning flashes all around. Now, people exhibit normalcy and optimism biases because they say, well, I've sat in stadiums before and I haven't been struck by lightning, so I'm probably not going to get struck by lightning this time either. But one of the things that's most interesting to me is that you see that this stadium is full as it's lightning, but if it were to start raining, people would flee that stadium with the quickness, right? Isn't that kind of odd that we're more concerned about getting wet than being struck by lightning and killed? But these are the sort of strange biases that cause actions like that. This is a hurricane. I think this is actually Hurricane Ian that made landfall in the southwestern coast of Florida. Now, it was a devastating storm. It was one of those multi-billion-dollar events, I think close to 175 billion. But many of the people, in Florida say, we lived through Hurricane Charlie several years ago, and we can live through this as well. But this was a different storm than Hurricane Charlie. And so it's really important to understand that our benchmarks, what we've lived through as benchmarks, do not apply in terms of today's storm. So this storm is quite devastating. All right, so let's move on from biases to literacy and mental models. These are also things that shape perspectives and perceptions about science. Now, over my years as a professor, as a scientist, as a communicator, these are just some observations that I have made anecdotally, and I wonder if any of my colleagues listening to me have observed the same thing. People can struggle with the concepts of probability, uncertainty, and risk assessment. People can struggle with things that happen in multiple processes, and people can struggle with concepts that cannot be simplified to their mental models of understanding. Now, again, just stop with me here and reflect. Are there any heads nodding at that? I suspect so. So, for example, I used to, I don't so much anymore, but I used to teach a basic intro to weather and climate course here at the University of Georgia. And one of the things that one of the things that we would teach in that class is about how a cloud forms. You can have this parcel of air. That parcel of air rises. As it rises, it cools adiabatically, which means there's no heat transfer. And as it cools adiabatically, the parcel also expands. And as the parcel expands and as it cools, it can cool down to the dew point, and then you get condensation, and that's when you get clouds to form. Now, what I just described, there were multiple things happening there, and I always found that students struggled with that, right? Multiple processes. I know for a fact that people struggle with this. Look at this. Read this with me. There's a chance of showers after 2 a.m., mostly cloudy. Chance of precipitation is 30%. Now, be honest with yourself. How many of you unequivocally are certain that you know what that means, 30% chance of rain? I'll pause for a second and let you sort of grapple with it internally, because this is one of those areas where people struggle with a percent chance of rain. The forecasters are trying to convey a confidence that a certain aerial coverage of the forecast area will receive rain. So 100% confidence of 30% of the area is 30%, but if the forecaster's 50% confident, it might have been a 15% chance of rain, right? So we're trying to convey, because rainfall is a very sort of, it varies in space and time quite a bit. So the best way that we convey it as threat is in a probabilistic manner. Same thing with the cone of uncertainty as a hurricane is approaching. All right. So people struggle with these types of things. Again, normalcy bias is another one. This is flooding that we saw last year in New York. Yet people, they make a calculated risk assessment that they need to get where they're going. So they'll drive through a flooded roadway, even though we preach, turn around, don't drown. Again, but there's a normalcy bias there. There's an optimism bias there. So again, I'm shaping the things that guide or sort of explain decisions that people make. Okay, so let's take that to the climate. We were talking about it from a weather risk standpoint. This is a look at carbon dioxide changes over the last 800,000 years using paleoclimate records, ice cores and such. Now, we clearly see something that climate change know, even though I could be standing in a mall or a Subway sandwich shop and someone finds out I'm a climate scientist and they'll say, well, Dr. Shepard, climate changes naturally. Of course it does. We know that as scientists. No, you don't have to tell us that. In fact, we see the naturally varying climate change here. We see the warm periods, the interglacial periods. We see the ice ages or glacial periods. But notice in terms of CO2, over the last 800,000 years, it never really kind of got outside of this bound of like the upper 200s to perhaps 300 until we reached the industrial revolution. And now in 2021, and we're up at 414 parts per million. So we're well beyond this sort of natural boundary over the last 800,000 years in our natural cycle. So before I leave that, I wanted to say one more thing because it's an important point. When we're talking about climate and climate change, it's not either or. It's not naturally varying climate or anthropogenic climate change. There's a naturally varying climate system, and there is an anthropogenic climate signal or steroid on top of that anthropogenic or natural cycle. So in the same way that grass grows naturally, when you fertilize your lawn, it grows differently. In the same way that home run hitters could hit home runs naturally, but when they use performance enhancing drugs, they hit longer and more home runs. So it's not either or, it's and. So I'm leaving boxes. Remember we talked about, we're talking and using shapes as our context. Now let's go to circles. If we think back to basic math, the area of a circle is calculated as pi r squared. The only way we can increase the area of a circle is to increase the radius. And so we also have to expand our radiuses as individuals and institutions. We've got to expand that radius to increase our area of thinking, increase our area of reach and impact. So it requires an expansion of radius. Let's go to triangles. I'm offering solution space now. Expand our radius. But let's think about triangles. Many of you are in an academic setting, and I suspect there are quite a few graduate students listening to me today. You are being trained, likely as graduate students, using this version of the triangle in terms of how you forge and formulate your thesis, your dissertation, research paper, perhaps your talk at the AMS this upcoming weekend or next week. We give all of our background, supporting details, and then 250 pages later, we tell you what we found. When we're communicating more broadly to the public or to policymakers or to the media, you have to give the bottom line right up front. You may only have 30 seconds on a media hit or 800 words in an op-ed or only a short amount of time before a congressional hearing. And so the way we are trained as scholars is fundamentally backwards from a communication standpoint when we're speaking more broadly. So I encourage all of our institutions to start thinking about more integration of media training, public speaking, public writing, and other sort of professional development as a part of our fundamental training of graduate scholars as well. So some strategies as we sort of close this out or think about closing this out. Let's make sure I'm not going over my time. I don't think that I am. We need to take inventory of our biases and our marinades. So I've sort of framed a discussion for you today about sort of what shapes some of our biases, what describes why those biases may have emerged based on the marinades that we grew up. So your homework assignment after this lecture today is to take an inventory of your biases and your marinades. I mean, literally sit down, maybe even list them out, and then actually think about, does that shape or affect how I view something that's anchored in scientific rigor, objectivity, in the peer review literature? Think about it. So ask why they exist, and then develop an action plan. So if you've seen my TED Talk, some of which is rooted in this discussion today, in that TED Talk, I included a clip of a former colleague of mine, Greg Fishel, who was a TV meteorologist in North Carolina, very popular in his market, I believe it was Raleigh. And for many years, Greg was a climate skeptic or denier, if you will, and he admits it. But he sort of took this inventory because he was a Penn State trained meteorologist. And if you hear Greg's sort of discussion, he talks about that. He said, I was trained to look at data, to understand data, consider the facts and so forth. And as he sort of grappled with that in his own training as a scientist, he actually began to look into the sort of climate arguments that he was making and challenging, and it sort of has arrived at a completely different position. Now, there is the I'm going to do my own research crowd out there, and that's certainly fine. But the sort of challenge there is oftentimes the do my own research crowd is not looking at the peer-reviewed literature or sort of credible data and so forth. They're looking at biased sources, gray literature, and the like. Remember, the peer-reviewed literature is our FDA approval on a new drug, if you will. Because anybody can go post a blog or write an op-ed or get on YouTube and say just about anything. So it's important that we understand the difference in those sources as well. Develop an action plan, evaluate your information sources. And I want to end on this final point here. Engage beyond the ivory tower. This is so important to me. You heard when I was introduced that I was elected to the National Academy of Engineering and the National Academy of Sciences and the American Academy of Arts and Sciences. Now, in each of those citations, it noted my work in urban hydrometeorological processes. Remember, I'm a scientist. My research is focused on urban hydrometeorological processes and extreme precipitation events. That's kind of my bread and butter if you go and look up my peer-reviewed literature and so forth. So I do all of those things. I lead near the top in my department every year in peer-reviewed publications, grant money that I bring into the department. So I do the things that academics are supposed to do. But guess what? Here's a secret. I tweet. I host a show for the Weather Channel. I write for Forbes. I testify before Congress. So I sort of try to shatter this narrative of the other stuff, because it's a question that I often get from colleagues and students. Well, how do you find time to do the other stuff? To me, that's a flawed narrative. That stuff that people in academia say is other stuff, to me, it's fundamentally wrapped up into my scholarship and my philosophy on scholarship. And so we need to sort of engage beyond this notion that we just do ivory tower things. Because at the end of the day, if you look at this graphic, even after COVID, trust in science and scientists are up 6%, right? You might have this sort of idea that science is under attack, and in some ways it is, but there is still a lot of faith in science and scientists as well. But we have to engage more to build upon and grow that goodwill. So with that, I think I will stop, and I'm happy to take questions at this point.
Well, thank you so very much, Professor Shepard, for this fantastic talk. So for the audience, please put your question in the Q&A box. And I will ask you the first question as the chair of this lecture. So you mentioned that you are on a study of for the National Academy on this impact of compound and wicked problems. And when will the study report come out? And I ask you this because Julie Wengler and Andres Wiener and some other colleagues and I are doing a research project on this kind of issue, how to assess the impact of climate shocks, multiple shocks, and COVID and other things on food system resilience and sustainability. Right. So any suggestions, how to address this kind of challenging problems, because we are at the beginning of this study. So I mean,
sure,
it would be very helpful.
Yeah, I'm trying to pull up so I'll answer your question, and while I'm doing that, I'm going to pull something up and drop it into the chat as well. So John Drake and I and others published a paper recently on this that can give you a good start until that report from the academies comes out. So I found the link. So I just dropped it into the chat. Hopefully you will be able to see it. There it is.
Okay, great.
The Academy's report will be coming out in a few months. We're in we actually are working on the draft report. We have the report, so we're just as a committee iterating on it now. It's about a 260-page report. It was focused on the Gulf of Mexico, and we had several focus groups in various parts of the Gulf over a 1 year period where we met with stakeholders and communities and sort of looked at this sort of notion of what we in this other paper call the collision of disasters, if you will. So I would invite you to take a look at that paper that I just dropped into the chat. In fact, I'll go ahead and, because I still have share screen privileges, I'll share it because it's relevant to the conversation here. So this is a paper that we published last year, Disasters Collide at the Intersection of Extreme Weather and Infectious Diseases. And so it was really more of a concept paper where we're thinking about the notion of exposure, sensitivity, and adaptive capacity. This is where that figure that came from that I showed earlier. And so we offer some challenges and perhaps path forward as you and others start to think about that problem.
That's great. Thank you so very much. Looking forward to read the paper, and
Yes.
that would be very helpful.
No
So there are several questions in the Q&A box already,
I see them.
Yeah, okay.
I'll just try to take as many. I see a question from an anonymous attendee that is asking about science, not scientism, taking science as religion, rejecting any suspicion. Yeah, I think that question is sort of assuming that scientists don't take critiques or suspicions. I think that's very much what we do as scientists. That's what the peer review process is all about. So I think a question like that, I think the key is if you're skeptical about a science or skeptical about a result, do the work and publish it and submit it for review. Just because you're skeptical about it and post it on Twitter doesn't mean your skepticism is valid. I mean, I think your skepticism might be just as equally rejectable as well. So the very nature of doing good science is to be skeptical and to challenge and to review and iterate on. That's the very nature of science. So I think we as a scholarly community must help those that sort of think that there is no room for critique or challenge. There's no room for critique or challenge when that challenge or critique has not itself been vetted. So that's important. So Stephen says, as a grad student, how do we design our program and experiments to try to tackle wicked problem? Or is that something we should just do in extension or outreach? No, that's a great question, Stephen. I think in some ways you might be working on problems that are very theoretical in nature, are very much, you might not see the connection to the broader. And so in some cases you might need extension and outreach. But I think that almost everything that we're likely doing in some way has a connection to a broader societal challenge or wicked challenge. And so even if your research may not directly sort of come to bear there, I just challenge you to always be thinking about how where your connections are. One of my roles in this associate dean's capacity is to sort of grow large, complex teams and multidisciplinary collaborations. We're trying to sort of break down silos. And of course, we're going to still need sort of basic research in certain areas, but increasingly we need to understand where the intersections and overlaps, complexities are. Is there a role for the local, George asked, is there a role for local communities? Absolutely. In fact, we're going to need the large scale Paris Agreement type things to happen, right? That's the only way we're going to reverse this global crisis. But local communities, through understanding who their elected officials are, understanding that there are even sort of quick changes that can happen. So for example, if we reduce CO2 emissions tomorrow, I mean, that's not going to immediately cool off Detroit, Michigan's urban heat island, but there are things that we can immediately do in sort of communities and neighborhoods to reduce urban heat islands or urban flooding and so forth. There are also ways that we can sort of help think about sort of bus routes. Maybe in an urban community, there's an open air or fresh market, but maybe the buses don't go there. And so, if there's a way to increase sort of, our lobby decision makers to change bus routes to be more sustainable and so forth. I've been involved in something here in Georgia called Drawdown Georgia. It's a sort of a way of thinking about the top solution, 10, 20 solutions in the state that can help us reduce carbon emissions. And some of them are very much require local and regional actions as well. And then Geneva says, thank you. One of my organizations, Wicked Problems, is managing Great Lakes fisheries, which involves working with people. What are some tips for convincing science to folks who with strong personal stakes and emotional back. Yeah, that's a really good question. On another talk that I give, and let me see if I can find, because I think that I do have it. I want to pull something up here because let me end the slide in that. I'm going to, hopefully I can find it here quickly. Open recent. Yes, I found it. Okay. So now I'm going to share the screen again, if I can. Okay, see this slide here? This is from another talk that I give on climate communication. And there's an acronym called ELFLAND. And I came across this by a guy named Steve McNulty, who is he was with the USDA Southeast Climate Hub. I don't know if he still is. And he said this is exactly the mechanism that he uses when he engages with stakeholders that are skeptical on a topic. Like he used the example of farmers, but he says he talks to a lot of ranchers and others that and sort of that have this. And so he uses this ELFLAND concept: establish contact, listen, find common ground, lessen mistrust. Then you can assess needs together, nurture, and deliver. So sort of find and connect to a common value system. And from there, I think he's shown results. Okay, so I'm sort of having a hard time keeping up with all the questions here. So oh, there it is. I lost the window. There it is. So Cindy, we can't see the question, so it would help if you could repeat. As you went through the various stages of academia, how apparent did you find these biases affect the perception of your work? I think I found that most strongly related to when I started engaging with when I would be asked to, go out into public spaces. Thinking within academia, I think we're all sort of from the same or similar marinades, even if we have different perspectives. But when you get out into the public space, on the media, congressional hearings, and so forth, you start to see these biases. I'll give you an example of a normalcy bias that I saw after Hurricane Harvey. I was on I can't remember what I was doing, but it was talking about the fact that, there's all this flooding in Houston after Hurricane Harvey. And one of the guys said, well, we live in Houston. We get floods all the time. So I didn't think it was going to be a big deal. But what he didn't sort of understand is that 50 plus inches of rain in a week is an anomaly event. You haven't experienced that before. So your benchmarks, your sort of experiences don't prepare you for that time. So that's where you kind of see those types of biases. So Ramji says, despite available of such scientific, so there in terms of science communication, I think one thing that it's always nice to have nice crisp questions. That's a little bit too much for me to read. So I'm going to try to go to another one. Cindy, we can't see that. Yes, I had hoped to see that link that Marshall put in the chat. Yeah, I don't know, Jack, if some people are asking for that link that I put in the chat. So I don't know if there's a way you can share it more broadly, or maybe I can put it in the Q&A poll. Let me just try that. Or if Jack can, I don't seem to be able to. Hi, some people believe in climate change as not scientists are proposing mitigation. And what do you think is next after we achieve net zero? Yeah, I don't really know the answer to that question yet, because we're so far from net zero that I can't even wrap my hand around what's next. Thank you for, let's see, how do you deal with the doom feelings of issues like, yeah, I'm not a doom and gloom person. So I think that I'm optimistic because we know what needs to be done. We know the solution space. It's going to have to be a mix of mitigation and adaptation strategies, as well as local and regional strategies as well. Okay, so I think that's pretty much most of the question. I probably didn't get to all of them. Oh, I wanted to address this. Oh no, I already did. That was about the wicked problems in the grad student. So, Jack, I think we are at a point where maybe we can pause.
Yeah, also there are several questions about, if you could address, that'd be great. The one after you address the question below Geneva, there were some questions below that. I was wondering.
Yeah, I skipped through some of them.
Oh, you skipped. Okay.
It was just too long. Science Communication 101, miniature meaning.
Okay, that's great. Yeah, so thank you so much. James, can you put link to the Q&A box? Somehow I was trying to do it, but I couldn't.
I couldn't either. I tried to put it in the Q&A.
Yeah.
Someone
But if people interested in the, please email me, and so I can send the link to you. So that'd be good. And in the meantime, so we'll find other solutions in the future. So.
And feel free to engage with me in social media on Twitter at Dr. Shepard 2013. Also, I'm on Instagram and Twitter, TikTok, various places, because again, I believe engaging beyond the ivory tower. So probably shouldn't end there because I actually do have a 10 o'clock meeting I have to step to.
Okay, great. Thank you so very much again for your terrific lecture.
Thank you.
Also thanks to the audience for participating in this lecture so actively. And so goodbye, and everyone enjoy the rest of the day or the night, depending on where you are. So thank you so much. Yeah.
Thank you, and thank you again for the invitation.
Yeah.